Advanced wireless communication techniques for remote sensing. Advanced wireless communication techniques for remote sensing. Remote sensing is the acquisition of information about an object or phenomenon without making physical contact with it. Wireless communication is used to remotely control drones and sensors, while also transmitting the data from sensors back to the base station. The ever-increasing demand for remote sensing has motivated researchers to develop advanced wireless communication techniques to cater to the application-specific requirements. In this article, we discuss various wireless communication techniques that are being used or researched for remote sensing purposes. Communication techniques for drones. Drones require reliable and low-latency wireless communication systems to control them remotely. The communication system must also transmit real-time sensor data from the drones. Some of the techniques being researched and used for drone communication are: 1. Wi-Fi. Wi-Fi is one of the most popular wireless communication technologies being employed in drones. Wi-Fi systems take advantage of the existing communication infrastructure, making it very cost-effective. They provide high bandwidths which are suitable for high-quality video streaming. 2. Cellular networks. Cellular networks are widely available, and many commercial and military-grade drones already have cellular modules installed, enabling them to communicate over cellular networks. Cellular networks provide a high bandwidth, making them suitable for high-definition video transmission. However, they are susceptible to signal losses and can also suffer from latency and speed issues in remote areas. 3. Satellite communication. Satellite communication is widely used in remote areas where the cellular network is non-existent, and Wi-Fi coverage is impractical for drones. Satellite communication is, however, expensive and suffers from high latencies, making it unsuitable for control of drones. It is more suited for transmitting data from the drones to the base station. Communication techniques for sensors. Sensors require different communication systems as opposed to drones. The communication requirements for sensors differ based on the frequency with which data needs to be transmitted, power consumption, and range. The following communication techniques are being used and researched for sensors. 1. Bluetooth Low Energy (BLE). BLE is widely used for low-power sensor data transmission. It is suitable for short-range communications between sensors, drones, and the base station. BLE is perfect for transmitting data from a drone to sensors, or between different sensors, but is not suitable for video streaming. 2. Zigbee. Zigbee is another low-power consumption communication technology suited for small data transmissions over medium distances between multiple sensors. Zigbee deployment is relatively easy, and its low cost makes it a preferred choice for many small remote sensing applications. 3. LoRa. LoRa, low range, is a wireless communication technology that can transmit data over long distances with minimal power consumption. LoRa is particularly adept in sending small amounts of data intermittently, making it an ideal choice for remote sensing applications that deploy many sensors in a single area. Communication techniques for both drones and sensors. For applications that require both drone and sensor communication, there are communication techniques that combine the strengths of both the drone and sensor communication systems. One such communication technology is: 1. RTK allows for precise positioning of the drone, which is critical for drones used in remote sensing applications. The technology also allows for real-time transmission of sensor data from the drone to the base station. The benefits of advanced wireless communication technologies for remote sensing are numerous. They offer real-time data transmission, low power consumption, long transmission range, and cost-effectiveness. With the growing demand for remote sensing in agriculture, weather forecasting, and land surveying applications, the development of advanced wireless communication technologies is paramount. Networks of sensors can work together to collect data from large areas, allowing for more comprehensive remote sensing applications. Apart from the communication techniques discussed above, recent research has focused on developing wireless charging techniques for remote sensors and drones. Wireless charging eliminates the need for batteries, which could be bulky and require frequent replacements, making them unsuitable for long-term remote sensing missions. Another area that is being researched is the use of artificial intelligence, AI, in wireless communication for remote sensing. AI can help in the optimization of wireless communication networks, improving their efficiency and robustness. AI-powered wireless communication networks can also adapt to changing environments, ensuring that remote sensing data is acquired without interruptions. As wireless communication technology continues to evolve and improve, remote sensing applications will become even more efficient, accurate, and cost-effective. The advancements will also make the technology more accessible for businesses and organizations that require remote sensing data for their operations. Remote sensing applications in agriculture have already become popular, allowing for precision farming techniques that optimize crop yield and reduce resource wastage. Such data can also reduce the impact of climate change on agriculture by providing early warning signals for natural disasters such as droughts and floods. Remote sensing applications also play a significant role in weather forecasting. Sensors placed in remote areas can collect data such as temperature, humidity, wind speed, and precipitation, which can be used to make accurate weather predictions. This information is critical in ensuring the safety and security of people living in areas prone to severe weather events. The use of remote sensing in land surveying applications has also become popular. By using drones and sensors, land surveyors can collect data on areas that are difficult to access, such as rugged terrains, forests, and bodies of water. The data collected through remote sensing can help in the planning and design of infrastructure projects such as roads, bridges, and dams. In summary, remote sensing is an essential technology that enables humans to acquire information about objects and phenomena without physical contact. The potential applications of remote sensing are vast. Advances in wireless communication technology have made it possible to monitor various phenomena, whether in the natural environment or industrial settings. For instance, remote sensing is used to study atmospheric dynamics, oceanography, and auroral phenomena, among others. In atmospheric studies, sensors measure various atmospheric parameters to understand how weather systems develop and interact with the natural environment. Remote sensing is used alongside models to forecast, identify, and track storms, hurricanes, and typhoons. In oceanography, remote sensing is used to measure sea surface temperature, salinity, currents, and wave height. This helps in the mapping of the ocean floor and monitoring ocean currents for navigation, climate research, and marine wildlife conservation. In industrial settings, remote sensors can be used to monitor various parameters such as temperature, pressure, and humidity. This is especially useful in environments where workers' safety is paramount, such as industrial plants, oil rigs, and mines. Wireless communication technology is also being used to enhance the safety and efficiency of transportation systems. For instance, remote sensors can monitor traffic flow and detect accidents or bottlenecks in real time. This is useful in optimizing transportation flow and reducing waiting times for commuters. Furthermore, the Internet of Things, IoT, is driving the development of even smarter wireless communication technologies for remote sensing.